We have learned how to analyze diode circuits with DC sources. Let's extend our analysis methods to include AC signals. AC analysis is broken into two categories: large signal analysis and small signal analysis. The words large and small are not rigorous. Let's define the difference. As with all semiconductor analysis, we have to deal with the nonlinear volt-amp relationship. How we deal with this depends on how large the input signal is in relation to the operating point for the semiconductor. If the input signal is large enough to move the diode through more than one region of operation, we use large signal analysis. When this is true, we can't ignore the piecewise nonlinearities of the volt-amp characteristic. We can still use linear approximations for the individual regions, but there is no avoiding the transition between regions. For small signal analysis, we can take a different approach. Even if the signal gets small, we do not avoid the transition between regions. To avoid the transition, we add a DC offset to the signal. As the diode is only going to be forward biased, it is worth focusing the VI plot on that region. The DC offset causes the operating point to be centered around a value away from the border of the forward and reverse regions. When the AC part of the wave is not included, we say that it is quiet, or quiescent. Quiescent point frequently gets shortened to Q point. When we turn the AC signal back on, the operating point moves around the Q point. As long as the AC signal doesn't move too far from the Q point, the tangent line at the Q point makes an acceptable linear approximation. Unlike large signal analysis, small signal analysis for a diode has the diode operating in a single region. Most of the time it will be forward biased. I suppose it could work in the breakdown region, though it isn't common. A reverse biased diode is effectively an open circuit, and AC analysis would be pointless. When the diode is in a single region, we can use the tangent line to model it and return to the safety of simple linear analysis. While we will look at examples of both types of analysis, we'll spend the majority of this series looking at large signal analysis, as small signal analysis has limited applications for diodes. So stay tuned and good luck.